Algebra Chapter 1, Lesson 9, and we want to wrap up this chapter and lesson by looking at dimensional analysis, and then we'll do a few examples where we calculate some quantities from formulas that we have. Now, when we're using formulas, the quantities that we have are always measured in units. Everything that we measure has units applied to it. If we're measuring distance, it may be feet or inches or miles. When we're measuring other quantities in physics, it might be like forces in newtons or something like that. But everything has a unit of measure attached to it. And when we use formulas, we want to carry the units throughout our calculation or throughout our computation. And this is called dimensional analysis. So essentially, dimensional analysis is using units when we're calculating. And the thing that we have to make sure is that our calculations or the units that we're using make sense in the calculations that we're doing. Now, an important note that when you're adding or subtracting and when you're using measurements in units, or the units of the measurements, they have to be the same. Okay, you can't add feet and inches per se. We need to have them both the same to make our calculation. Now, our answer may come up with a number of feet and then some inches, but that's different. The actual mathematical computation, the units need to be the same in order to make them make sense, and then at the end we can change them into something that's a little bit more presentable when it comes to how we're talking about things. But the actual computation process, the units need to be the same, and we want to carry these dimensions throughout the whole calculation process, and we just need to understand that the words can be calculated or used. We can apply mathematical operations to the words just like we can to the numbers. Now, that's a whole lot of information that I cover very quickly. Let me do a couple of examples, and hopefully that'll make things a little bit clearer for us. So in our first example here, they give us a formula D equals R times T, and then it explains to us what those variables represent. And remember, we talked about the key. One of the keys to understanding or using formulas was to know what the variables represent, and they're always going to explain to us what they represent. So D represents the distance that an object travels, R is the rate of travel, and T is the time that the object actually does the traveling. Then the problem tells me what I need to determine. So it says to determine the distance traveled by a moped moving at the rate of 27 miles per hour for a time of 8 hours. So I'm going to use this formula to calculate the answer. Now, it says determine the distance, and distance is the letter D. So D is the unknown. D is what we don't know, so we need to figure that out by multiplying R times T. So now I'm going to substitute in the values that they give me for R and T. R is the rate, so in the problem I'm looking for the rate, and it tells me it's 27 miles per hour, and per is a fraction bar, and so we're going to put that there like this. And then it says for a time of 8 hours. The time that the object travels is the T, so that's going to go here. So hopefully you'll notice that all I've done here is I've begun to evaluate an equation. I've taken the equation, I've rewritten it using parentheses, and then I'm substituting in numbers that they give me for the different variables. So now I'm going to apply order of operations to simplify this. So D is equal to, now I notice that I have an hour in my numerator here. I can write this as a fraction over 1 and a denominator, and any value divided by itself is 1, so the hours I can reduce to a 1. So that leaves me with just a 27 miles then times 8 hours, or no, the hours were reduced out, excuse me, so times 8. So all I have to do now is my multiplication, 27 times 8, that's 20 times 8, which is 160, and then 56, so that's 216, and then I still have my units miles, and so this is my answer. So the moped traveled a distance of 216 miles. So you can see how we began with our units and we simply applied the math to those units just like we did the numbers, and then we simplified the problem and we came up with 216 miles. Now, does that answer make sense? Well, a distance measured in miles makes sense. 27, 8 hours, it's a long time. 200 miles, I think that answer makes sense, so we'll go ahead and stick with it. Okay, so understand what the variables represent, then simply evaluate the equation, substituting in the values that they give me, keeping the dimensions in mind as we do it. Okay? In the next example, they give us the perimeter formula is 2 lengths plus 2 widths. And again, it explains to me what they represent. I kind of read that or told you what it was already. P is the perimeter of a rectangle, L is the length, and W is the width. Okay? Determine the perimeter. So again, my perimeter is my unknown, so I'm going to have to know what the lengths are plus the 2 widths. All right, so then I can go ahead back and substitute in the values that they give me. Now the length is 9 feet, so that's feet, and the width is 48 inches. Now, I notice here that I have feet and inches, so I can't work with that being different. Those both have to be the same. So I either have to convert my 9 feet into how many inches that is, or my 48 inches into how many feet. Now, generally speaking, it's easier. Well, I noticed that it's easier to convert this 48 inches into feet. That's going to be a smaller number than multiplying 9 feet times 12 inches and getting a rather large number. So I'm going to go ahead and convert this feet into inches. So I'm going to go ahead and multiply this out because I know I'm going to be ending up working with feet anyways, plus 2 times, now how many feet is 48 inches? Well, 48 inches is 4 feet, so I'm going to change that into 4 feet. So then I have 18 feet plus 2 times 4 is 8 feet. And now I can go ahead and add these because these are like terms. Their units are exactly the same. If they were different, I wouldn't be able to do that. And so remember, when we're adding like terms, we simply add the coefficients. So 18 and 8 is 26, and then I keep the units, so 26 feet. So a perimeter here of 26 feet. So again, understand what the variables represent, substitute them in, and then make sure the units are the same in order to complete the calculation.